In a previous video, I went over how you might try to handle a roof with two different slopes or two different pitches, and how you might find some of the angles in a 3D model. But I realized that that's useless for people who are on site and trying to figure this out on site. So I'll show you how we figured this out on our site. Special thanks here to Master Carpenter Kevin Horn. So go back to the other video if you want to see a few of the different problems that crop up. I won't go over all of them again, but look at the other video for that. So I've got a 3.5 and 12 on the left, and a 5 and 12 here on the right, and I've got some funkiness with two different valleys. What I'm going to try and go over is how you might handle trying to line up that common rafter and fascia and that common rafter and fascia, and then I'll show a little bit of how you might try and figure out your valley rafters and give you some sense of how to lay out the difference in top plate height. So hopefully you have a big piece of plywood or even better, a concrete floor to work on. And clear off your floor, sweep it off, get your framing square and your tape measure and your pencil and maybe a long straight edge. If you've got a framing square, you can use it to snap through some nice perpendicular lines like that. You can check yourself by making a 3, 4, 5 triangle. If you go 3 feet and 4 feet and you pull your tape across the hypotenuse here and it doesn't add up to 5 feet, then something's wrong. And that'll be a nice grid for you to, anywhere along here you can just butt your tape there and pull off in a direction parallel to that line. So what I've done is I've set up how you might start doing this. And I'll start with the left side here. This is my 3.5 and 12. So you've got your lines here as your guides, and you get your tape measure and you measure 3.5 and you measure 12, and it might not be as easy as what I'm doing here, but you can do it. And you would draw that there and you would snap through and pull that line right on through, and that is the top of your plywood. And what you want to do is have a line, one of your perpendicular lines here, and you're going to use it to line up the top of your plywood on the other side when you do the other roof. So you want to have a line that you're working on and you want to be on the same line for the other one. So you've established the top of that line, and then you would offset that line 5/8. So you make another line parallel to it, 5/8 inch across, or whatever your plywood is. Just make it the same as your sheathing. And then you take another line, and in my case it'd be about 5.5 inches, whatever your rafter is going to be. And now you've established the rafter. Okay. Then on the other side you want to do the same thing. So I've got a little 12 inches here and 5 inches there, and that is how I establish my pitch. I start on that same line, and I've established by snapping through those 2 points the top of the plywood. And then you offset that 5/8 or whatever your plywood is. You offset that whatever your rafter is, in my case 5.5 inches. And then you've established the other common rafter here. So now we have both common rafters. And what you can do then is you can make your level cut on the end of your rafter. So wherever your slope meets that line, you want to measure over whatever your overhang is. In my case, it was 30 inches. So I'm going to go from this line that's made right there, and I'm going to offset, measure over an additional 30 inches that way, and snap a line right there. If you snap that line and carry it through, and it's nice and parallel to your line here, so you can always double check with your tape, that gives you the edge of your top plate. Now you can grab your tape measure, your framing square, and you want to be perpendicular to that line there, or parallel to this line here, right? You're going parallel up this way. And what you want is, whatever your top plate is, if it's 3.5 like mine is, you want that little bird's mouth cut to be 3.5 inches. And so this portion here is going to be parallel to that, and the top edge is going to be parallel to this, and that's 3.5 inches from there to there. So that's the little bird's mouth there. You repeat the process on this side. You want to be 30 inches from there to there, and that sets up most of this. Now the other thing to keep in mind is the fascia, and I grabbed some little fascia boards here just as an example. So I'm using something that's 1.5 inches by 7.25. You use whatever you got. But if you're doing that little cut, I'll go back to 3D for a second. If you're doing the little cut that makes the plywood sit nice on here, you're going to have an angle here, and you're going to have something a little different on this one. This is one of the issues. Well, if this is 7.25 starting there, and this is 7.25 starting here, you'll notice that the bottoms don't line up. So you're going to want to have a plan in mind for what to do there. There's a couple ways to approach it, but you might have to cut that one a little short to make them line up nicely. Just to go over the speed square just a little bit, so this is my attempt at showing a speed square. If I put my speed square like that, I am perpendicular to my little line that I've made, right? So this is the plumb edge right there, and I look at what that angle is. It's about 16 and a something, 16.3 right there. So there'll be an indication right along there what that is. Now this is my 3.5 and 12. This is my 5 and 12. So it's about 16 and 22 or so. If I look at a little picture, there's a 3.5 and 12. Here's a 5 and 12 common. If I zoom in, and this is sort of approximate, you'll see that there's a little spot there on that for common, and up here it says hip and valley. So we'll ignore hip and valley for the moment, and you butt that up against your wood there, and there's about 3.5 right there. 1, 2, 3, 4, so 3.5, and here's the degrees, so it's about 16 and a something, and that looks about right, 16 or so. If I look at the 5 and 12, so again we're looking at common, 1, 2, 3, 4, 5, so there's 5, that's about 15, 20, 21, 22, 22 and a something, and there it is. So that gives you a sense of how the speed square helps you out there, and how you would do the common rafters to get those to align. And what you'll notice is you have your top plate here and your top plate here, and you can take your parallel line here and figure out the difference in height of your two walls. So that sets you up for that part of this. Now, what about the valleys? Now there's some complexity I won't get into in this video about these cuts here, but I want to look at the seat cut for these two different valleys. One thing I'll point out here is if I go to my little 2D view here, if I pull off of where these fascias intersect right here, and I go back to my wall, that's 30 inches. And I go back to the stud wall here, and that's 30 inches, right? But if I go from this spot right here, and I go back diagonally like this at the valley, it's something like 3 foot 6 and 7/16. So it's a different distance. So this is my version of the same exact thing with the valleys. You have your nice little grid line snapped out on the concrete, so you can pull parallel off of that, and you draw things up a little different. So this is the 3.5 and 12 valley and the 5.5, or the 5 and 12 valley, and this is approximate. So I've got the speed square. I may have missed it by a little bit here, but I'm now looking at the hip and valley portion, and that's supposed to be about 3.5 at the hip and valley, right? What I'm going to do is I'm going to go down here to the common, and I see that that's close to 2.5 on the common. And so what I do is I've got my 12 inches here and 3.5 inches there, because this is a valley rafter, if I use that, you'll notice that it gives me the wrong angle. So I'm going to ignore that for a second. If you remember when we went from the hip and valley number and we went down and looked at what that turns into on the common, that gives us a degree here, or about a 2.5. So I will snap out 12 inches and 2.5 instead, and I'll drop that right here, and it's close. It's not perfect, but it's pretty close for the cuts you'll need. And so you'll see that that's not quite, it's close. That gives you your slope for this. So you snap that through, you do the same thing, you snap your 5/8 for your plywood, and you snap your 5.5 or whatever it is for your rafter, and then you're going back a different distance now for your top plate. Now you do the same thing for the other one. So on the 5 and 12 valley, here's 5 on my little valley marks. Bring that through to the common, and it looks like 3.5. And so once again, if I were to try and do 5 here, it doesn't work, right? So instead I do 3.5, which is what it showed up as on the common, and that's pretty close. And again, I may be off just a hair, but it's very close for the cuts you'll need to do. And so that establishes your slope. You offset the 5/8 for the plywood, you offset for your rafter, and you again, you want these to be on the same line, so you can tell the difference in the top of your wall. You measure that down to your same line parallel there, and then you know what that is. So that's a little mock-up for how to do the 2 different valley rafters. You can look at the previous video for the other annoyances that show up as part of trying to meet these kind of weird scenarios in a valley. If you're having a problem, you can also just snap out on the floor a plan view of your top plates like this and a plan view of your fascia. That way you know from here to here is 30 inches, and from this inside corner here to your wall, you'll know what that distance is if you just snap it out on the floor. And that's how you'll get that number right there, and that will give you how to align the edge of your wall here. And again, this is, it's just 3.5 inches, and it's parallel to this line here, and the other side of it is parallel to that line there. So hopefully that was useful. All right.